Well, now that I know that there's no way out of a 127 tooth gear for accurate work, I've got to figure out how to cut one of those things. And normally I would hob it. I've built a gear hob attachment for my milling machine, but I couldn't find a 20 DP hob with a 14.5 degree pressure angle, which is what that gear requires. So next best, I guess, would be my differential dividing head. This is an interesting device. It was designed by George Thomas. He was just a tremendous machinist, model maker, designer, writer. I read the original articles when they were first published and came out in Model Engineer 40 or 45 years ago, and then built this from a set of castings that he made available. It's a very clever design. I'll just go over a couple of unique features. Right off the top, it's a 60-to-1 mesh for the spindle. In the main gear has 60 teeth on it, and so turning the handle once gives 1/60th of a turn, which for a 360-degree circle is 6 degrees. Now that's an important detail on this particular head. The next thing that's important on this particular head is this wheel of 60 holes. And this wheel of 60 holes, if I go around once, like I just explained, that'll be 6 degrees on the spindle. But if I just go one hole, then that would be 6 degrees divided by 60 is 1/10 of a degree. Okay, that's pretty good. But then we have another little feature on this, which is the differential. And this thimble is connected, maybe I can show this, is connected to a worm right here that's connected to a 60-tooth worm wheel back behind this plate, and it can rotate that plate. And the handle or the knob for this worm has 100 divisions in it. Now, let me tell you what all this means. It means that one turn is equal to 6 degrees, one hole is equal to 1/10 of a degree, and 1/100th of a hole, that would be turning this knob, which turns that gear, which turns this plate, which turns this handle, which turns this gear, which turns this spindle, is 1/1000th of a degree. And I think that's pretty interesting, because this gives us some pretty interesting ways to work on prime numbers in thousandths of a degree. For our particular problem here, the 127 tooth gear is, oh goodness, it's 2.846, I think, degrees per tooth on that 127 tooth gear. So what we would do would be to cut that, we would set, since each of these is 1/10, each of these holes is 1/10 of a degree, in order to get 2.8 degrees, we'd set up 28 holes. So that's 2.8 degrees. Now we still need the 34 thousandths plus some, but not 35 thousandths, 34.5. And so for the first index, what we would do would be to move that down there, 28 holes, move the sectors over, and then go, that's 20, 40, I got to go back some, Oh goodness, my eyes are terrible, and these lines are divided fairly finely. So there's 20, there's 24, and for this first one I'm going to go 25. And that's a little too much, but the next one I'll go 23, then I'll go 25, then I'll go 23, then I'll go 25. And it will average it out within, in theory, 1/1000th of a degree. I think that's the best way I'm going to have to get that 127 tooth gear with the equipment that I've got. Better equipment, of course, would work a little better, but this is what I've got. And like I say, I would hob it, but I can't find a 20 dp, 14.5 degree pressure angle hob that's a reasonable price. Reasonable for me is not very much money. So I'll set it up with the dividing head. Normal gear cutter, probably, I think it's a number 2, is it? I think that goes up to 135 teeth to rack. So that goes between 15 and 135 on number 2. So that'll, use that to cut the teeth, use this to get within about 1/1000th of a degree, and hope that that's good enough. I hope that's clear. Again, this 28 holes, all right, would give us 2.8 degrees, and then we start having to add up 35 notches or 35 divisions on this knob to turn that around. And so I'll put that all probably on a spreadsheet so I always know where I am, because it'll be easy to forget where you are on this thing. Hope my memory's good enough. Wish me luck. Well, back again. Kind of a good news, bad news episode here. The good news is that, well, maybe I can start with the bad news. That gear that I have to cut is actually an 18 degree, or pardon me, an 18 dp, 14.5 degree tooth profile. That's the bad news. The good news is I have a hob for those, and this is it. This is, and I don't know if you can see that, probably not. Anyway, this is DP 18, 14.5 degree, 1.3 or 1 degree, 35-minute helix angle. That's the angle that the teeth are on the helix here. And I got that for a reasonable price out of China, of course. And in fact, it actually cost less than a set of cutters. So that's good news. The other good news is I hadn't cut that gear yet with the way I was going to do it. So I'll be hobbing that large 127 tooth gear. And I guess sometimes you get lucky. So don't ask me how I made that mistake. Really not, it's kind of a painful story. But I got it figured out that the gears on a South Bend lathe, the ones that come off, that go through the tumbler reverse system and come off the spindle, are 20 dp gears, and the change gears are 18 dp. So, since I'm in the change gear section, we'll be doing 18 dp, 14.5 degree pressure angle gears with a hob. So no dividing. Piece of cake. Thanks. See the lines barely there. Do that with our little saw. And 5 minutes later, it's cut out. Came right out of there. Voila. Okay, I'm doing some back facing on this bore right here with this tool right here. Has quite a bit of clearance on the front, so I can come along. I can feed it through this bore to a predetermined 0 point. That is 0, which I'm setting over there, and then I can come in 1, 2, 3, 4, 30. That would be the point that I'm trying to back face to. And then I would set that, and then I feed out 200 thousandths, and it will back face. I wonder if I can see in there. I've counterboarded already, done the back facing. You can just see the tool in there, and that's to the finished depth. I did it in 2 cuts, or 3 cuts, I guess. And it seems to have worked out fine. Now I have a face that is parallel. This face right here was faced when I did that bore, and I haven't moved it since, so I end up with 2 very parallel faces, so I can work both sides of this blank. And then when I want to retract this, I have a little stop set here so that the retracting always comes out to the same spot and I don't overrun and cut into the back of it over there. And in theory, this should all retract now, and it does. How about that? Here's that back facing job that I just showed in the lathe, that back face. So that face there should be quite parallel to this face here, since they're both faced at the same time. This is faced over the whole blank, and this is just faced out to here because that's all the reach I've got. But it allows the next series of operations to be carried out, I hope, truly. Okay, this is a trial setup for cutting this large 127 tooth gear for the South Bend lathe for cutting metric threads. There's where the keys are placed. This is just a kind of a general setup. Those are 3/8 lathe tools underneath that 1, 2, 3 block to raise it up 3/8 of an inch up to center height. That's a little bearing that runs out of true 2,000th TIR. And that's the way the setup looks. So it's all got to be squared up, and but it looks like it'll fit. The one thing I have to do is take off this handle to get a little more movement out towards me of the table so that the hob will clear the blank. And then I think we would be ready for a trial. Okay? Cutting the 100-tooth gear here. This will be a full depth cut. I hope it works. This is the new motor that I put on here. It's a hybrid. Resolution now per revolution is 9,000 pulses. And I have a similar one back there. Feed is 5 thousandths per rev. That's as fine as I could get it, so we're going to see how this works. Not going very fast, but we'll just see. So far, I think it's working pretty good. We'll see. Oh, interesting thing, I have a little follower right there, a bearing, that takes some of the load of the cutter. It's an awfully big blank. I think it's 5.166 in diameter. And so that bearing takes some of the load of the cutter, which is, of course, right there. And the depth for the tooth is very close to 120 thousandths. And there's our feed going along. As you can see, it's pretty slow. Okay. Getting a little louder with every rotation. Okay, so far so good. Okay, I've got this thing around a little bit faster. I'm wondering if it isn't that bearing right there that's causing me problems. It seems to have a flat spot on the part that's touching the gear. So I'm running it just a little bit faster now. Used to be running at about 16, 17. That means nothing in RPM, but it's running faster now. And although it's going, it looks like on the camera that the hob is spinning to the left, it's actually spinning to the right. Almost done. Well, my ear tells me that that thing's cut through. And so I'm going to turn it off and see if it meshes with the gear. Maybe I'll pull a gear out and see if it meshes. So there's the mating gear. And I think it looks pretty good. I can get that in a little better focus. Okay, this is another project. This gear will mount as a cluster, or part of a cluster with the previous gear. This one's a little bigger, quite a bit thinner. This is 3/8 of an inch wide, and it's 7.166 in diameter. It'll have 127 teeth cut on it. Again, I've got my little bearing there. How do I point that out? There. That bearing, which will be a kind of a shock absorber for the concussion of the hob as the teeth pass through it. That's a big gear, fairly thin. These are Delrin. I was afraid that these things would rattle around quite a bit, so that's my fix for it. and we'll see how this baby works. The helix angle will be the same for this. It just barely makes it. There it is. Just barely makes it. And here I had to take off my Y feed handle so I could get enough clearance coming out this way to get the hob behind it to start. This is pretty much the limits of this machine, at least the way it's set up, and I hope it works, because this is my only material, and if I screw it up, I'm done. Okay, well, there it's engaging. I'm just nicking it to make sure I've got the right number of teeth on here. You can see the first little cut coming up on the tooth. Don't know why all that stuff's on there. Okay. Looks like it's got the right gap to it. Okay, and through the magic of the internet, I've assembled this gear cluster for cutting metric threads on a 9-inch South Bend lathe. This is a 100-tooth gear. This larger one is a 127-tooth gear. I've shown the video on, at least partially making these things, of the details. There's quite a lot of work in them, at least for me. And so to finish this up, I've just pushed a bearing into, now it's a steel bearing, and I think with enough oil I can make that last a while. Maybe oil light bearing would have been better, but this, for some reasons, is the way I decided to go. That's about 1.5 thou press fit in both of these blanks, or both of these gears. And then I just put in a couple of countersunk Allen head cap screws that thread into this thicker gear. That would be the 100-tooth gear. There's plenty of meat there. These babies are never going to slip. And I think it runs pretty good. I think the user will be happy with them. Thanks for watching. Really appreciate it.